Oh, I didn't see you there. Oh no, we gotta get the fast layer. Let's go, let's go, let's go. Watch out. Oh no. All right, hurry, come on, let's go. When the force of friction acting on an object is not given, we can use Newton's second law to find it.
As you can see on the back of our card, there is a tension block, friction block, and when acted upon with tension, it will be pulled in the opposite direction as friction. Now this raises our problem because we do not know exactly how much friction is being acted upon the track.
Okay, so in order to find friction, we're going to use free body diagrams. As you can see on this whiteboard, I've created a free body diagram for the mass that's going to be hanging off the end of the track and for the cart. But there are multiple unknowns. We don't know the force of tension, we don't know the force of friction, and we're not sure of the acceleration. However, we can solve for tension in the sum of forces statements. As you can see here, we will mathematically calculate acceleration, which will allow us to find friction. As you can see on the sum of forces statements, I have set both of them equal to tension and solved for them. So I have an equation down here. Friction is equal to the mass of the weight times gravity minus the mass of the second weight times acceleration divided by the mass of the cart times acceleration.
So we will be modeling the setup for this lab. So we will start by taking the bump stop and we will attach it to the track that you have. And we're attaching the bump stop to the track so that when the cart rolls, it'll stop at the bump stop and it won't fall all the way over through the track. And then next, we're gonna attach it at the 40 centimeter line. Next, we're gonna take the pulley that we have and we're gonna attach it to the end of the track so that the string and the track are seamlessly connected. So next, you would take your cart and you attach the friction block to the end of it so that there's friction acting upon the cart. Then you would take the cart and you would place it at 140 centimeters. That's 1 meter away from the bump stop. And you would place the cart on the track so that the friction block is facing the opposite side of the pulley. Next, you would take your weight and attach a string to one side of it and take the other end of your string and pull it through the bump stop and attach it to the end of your cart so that when the weight falls from the pulley, your cart moves along the track and stops at the bump stop at exactly the same time as the weight hits the floor, because the distance from the bump stop to the cart is the same distance as the pulley to the ground.
The math behind this experiment can be explained by this equation here. X equals x naught plus v naught t plus 1/2 at squared. For this equation, we will be using the weight to monitor time and height. We will call this our x naught, so it'll be starting at 0. The object is at rest, so our v naught will be 0, allowing us to simplify the equation to x equals 1/2 at squared. Using the Huddle Technique app on our phone, we will find time value based on the height. We will create a chart of time squared, and x being the height. We will create a graph of time squared on the x-axis and height on the y-axis, allowing us to produce a graph with a slope of 1/2 at squared. By multiplying the slope by 2, we will be able to find acceleration and mathematically determine friction. So we're going to let this experiment run. I'm going to release the cart and the weight's going to descend and they're going to take a video of it.
Perfection.
After completing the trials that you needed with your 50-gram weight and appropriately recording all the sets of data that you needed, add another 50-gram weight to the first 50-gram weight and then record your data again. Then, after you're done with that, add a third weight and record your data again. So then you'll end up having 3 sets of data with different trials of 50 grams, then 100 grams, and then 150 grams. Thank you.
Alright, 3, 2, 1.
After completing your set of data and and repeat the trials and record your data again. After you do that, you're going to add an additional 50-pound weight. So you're gonna end up having
Said 50-pound weight.